Hello and welcome back to a series on learning Java. Today we will be talking about the very first part of Java language, which is variables. So let's start by declaring a variable. Well, actually, let's start with what a variable is. A variable in Java is a way to tell the computer to store something, a value, an object. It can be very big, it can be very small. The most useful kind of variable, or the most used kind of variable, is a number. And our most common way to represent numbers is called int, short for integer. So we can declare a variable by typing int. Int. It tells us it's a type. The type of our variable is int, integer. And then we give it a name. I'm going to call this one number. Now, that's an entire line of code. We can stop there and end it with a semicolon. We've declared a variable and we've told our memory that we want to allocate some space for this variable number. Well, it's not very useful right now because we haven't told it to put anything there. So let's give our program a value to put in the space that we're calling number. We type the name of our variable. This is the space that we're going to put a value into. And we put an equal sign. This does not mean equals in the mathematical sense. It's called the assignment operator, which means it takes everything on the right side and then puts it in the value that we specify on the left side. So if I say that number equals 100, line of code, it takes the value 100 and assigns it to the variable number. This is one way to declare a variable, and this line here is called initializing, giving it an initial value. We can do both of those in one line of code, and you'll see this a lot more often. So I'm going to use a different kind of number now, called short. And int gives the memory 4 bytes of space to use a number with, and that gives it up to about 2 billion and down to negative 2 billion. Numbers can be negative. A short is only 2 bytes, so it's about a million, I think. So let's call this small number because it's going to be smaller than our number, and we can assign it to the value 3. Right. Now there's an even smaller type of number called a byte. This is, as the name suggests, 1 byte. It only goes up to 128, down to negative 128. And as I said, numbers can be negative, so this one's a negative number. It's negative 2. And then the biggest standard kind of number is a long. That's 8 bytes. I'll call this one huge number. And give it the value 1 billion. That's 9 zeros. And then you have to end a long with the letter L, and that tells Java to parse it as a long. If you don't give it the L, it'll try to save that as an integer, the int type, and if it's too big to fit in an int, it won't work right. You have to give it an L to tell it that you want that number as a long, and then store it in a variable with the long type. I'm going to declare one more variable. That's an int. I'm calling this one other number. For right now, I won't give them a value. We'll see that later. Now, all of these types that we've talked about, that I've talked about so far, byte, short, int, and long, are only for integers. You can't do fractions, decimals, anything like that. So if you want to use a decimal, you have to use other kinds of data types. The basic one is called float because they're stored in a floating point system. There's other places you can find out what floating point means, but for right now, we're just going to call this float. And basically everywhere you're going to see decimal stored in a computer, it's using a floating point system. So I'll call this one decimal, because it can store decimal, 0.1. And then I have to add an F. Similar to long, I have to tell the computer that I want to be storing that number, 0.1, as a float and not try to parse it as an integer, because it won't work if it thinks it's an integer. Now there's a bigger kind of floating point number, which is a double. It's double the byte length, I think. It's not important. the most common data types are int and double, because they give you most of the breadth you need. If you run into issues using int for an integer, you can use long, but generally you don't want to try to constrict yourself too much by using lower memory data types. And I'll call this one any number. Can be as small as you want. They're not. If you try to put a bunch of different digits, it might not save all of them correctly because the computer is storing in binary instead of in decimal, and it can only store with a particular amount of precision. If you give it a bunch of zeros, it just sees the 1, and the 1 is all it cares about, and it'll figure out how to deal with the rest of it. Okay. Now, these are all numbers. There are a few other data types that are not numbers. One of them is called char, short for character. I can give it a value. It has to be just one character long as text, and it has to be one of the 90 basic ASCII characters. There's this website called ASCII, ASCII.cl, and you can look up all of these characters. We surround these with single quotes. That is important because there are other things that double quotes are used for, so we have to put chars in single quotes. We can also define a char using a number. So 65 is the number that corresponds to the letter capital A in the ASCII system. So this, if I told it to print this character right now, it would print capital A. Even though that's not what's stored there, it knows that 65 as a number represents character capital A. Now you'll see that print is giving me the red squiggly line, and in VS Code that means something's not right here. That's because I haven't defined the print method. It's not automatically defined in Java. There's a different command that you can use to print things to a console, which is where you get an output. For these videos, I'm just going to be using print because it's a lot easier to type than the other thing, but I will show you how to use the other command that will actually print things. Just know that every time I type the word print, it's going to give me a red squiggly line telling me that's wrong. And I'll show you in this green text over here what it will actually print. And there's another way we can represent text, and this way is a lot more common, using string. Now, string is interesting because all of these we've seen so far, the type names, start with a lowercase letter. And what this means is that they're called primitive types. They're all stored as numbers in the computer. Strings are not. They're more similar to objects, which we'll talk about when we talk about classes. It stores a lot more information than just a number, but it's also automatically defined in Java. No other kind of object is. So some people think of it as a primitive type, and some people think of it as a non-primitive type, which is when you define it yourself. It has this capital letter because it's an object, not a number, when it's stored. It's also common to represent strings as str, short for string. And then these is where we talk about the double quotes. As I said, strings are a lot more common than chars because chars can only represent one character. Strings can be as long as you want. They can be one character. They can be 0 characters. They can be as long as you want. And there's one more kind of data type that's automatically defined. That's called a Boolean. A Boolean is true or false. It can't be anything else. Usually our names for these tell us what might be true or false. So we know that Java is cool. So this value is going to be true. Now we'll talk about some operators that we can do on these variables. First, small number plus number. Now when we see this operator, small number plus number, I'm going to use the print command. Even though we're not really printing this, it makes the editor like me a little bit more. This plus operator tells us to add two numbers. Pretty self-explanatory. We know that the value currently stored in number is 100, because that's the value we told us to put in number, and the value stored in small number is 3. That's the value we told it to put in this space. We haven't redefined either of those variables, so those are still going to be what's there. So when we add them together, 103. Math operators are pretty self-explanatory. we've got minus, number has 100, minus 20, that's 80. Number 7, the asterisk represents multiplication. Negative number has -2, times 7 is -14. I do huge number divided by number. We're going to use a slash to represent division. This is going to be 1 million. No, 1 billion is in the long, is in huge number divided by 100 should give us 10 million. I don't know for sure if this will store as a long or as an int or as something else. Often division will return a floating point, so either float or double, because the computer doesn't know before it does the calculation whether that's going to be, whether number perfectly divides huge number or if there's going to be a remainder. And if there is a remainder, we're going to need to have some decimal places in order to calculate in order to save what that remainder is. So usually division will return this as either a float or a double. I think it's as a double. And there's one more math error. Which is the percent sign. Nope, character. Okay. So what is this going to do? Well, percent doesn't make any sense. That's not two numbers. This is not what it looks like. The percent operator in code, and this exists in most programming languages, is called the modulo operator. We talked about how division will give us a remainder if it's not going to be a perfect division. So in this case, 1 billion divided by 100 is 10 million. That divides perfectly. But if it didn't divide perfectly, we're going to have something left over. Percent sign tells us what we have left over. So there's another issue here, which is that we haven't given a value to other number. So I can't figure out what this is because other number doesn't have a value. If I try to print this right now, this will throw a big error. Because I haven't defined anything. Let's add another line that defines what other number is. I'm allowed to do this at any point. It doesn't have to be only up here when I initialize it. I can redefine these numbers as much as I want. So I'm going to add this line where I'm redefining the number, and now I can do this calculation. When I divide 35 by 3, it will give me 11. 33 is 11 times 3, and we'll have 2 more parts left over. So the percent operator gives me the 2. It doesn't work. Even though the division would come out to 11, we don't see the 11 again. Sometimes you'll want it, so you have to use the slash and the percent together, but the percent operator will just return the remainder too. Now let's do some string operators. Remember, string has the value text here. I'm going to add this to a string that says more text. Notice I put a space at the start of that. This operator, this plus, is not the same as math plus. It's not like we're adding two numbers together because strings aren't numbers. We can't add them together like numbers. Instead, it's what's called concatenation. It's going to put the first string and then the second string right next to each other and just put that value. So this will say text here and then start the next string immediately. That's why I put the space. And there's a space between these words. More text. If I hadn't had the space there, it would put here and more right next to each other without the space. Now let's make it funky. I have a string and a number. What's it going to do? I can't just add them because, again, strings aren't numbers. I can't add a number to a string. So it's going to concatenate. But first, it's going to turn small number into a string. It basically just adds quotes around it. So text here, and then the 3. Remember, there's no space there. I haven't put a space there. If I wanted a space, I'd have to add the space and manually stop it. Sorry. I'm going to do one more. String plus a. Remember, a is our char. That has the value a. it's all the way up here. This doesn't work. You can't add strings to chars, and that's why chars are not very helpful. You can't do anything with them, really, except print them and redefine their values. They don't interact well with other kinds of data. Now let's look at some logical operators. I'm going to define some more booleans. This one. So remember, assignment. That one equal sign means assignment operator. I take whatever's on the left side, the right side, and put it in the value that I stated on the left side. So I'm going to put in the expression is a small number equals 3. Why did I put 2 equals? Because now I want to check if two things are equal. This is more similar to the mathematical equals. But because the 1 equals is the assignment, I have to put 2 equals to tell it I want to compare these values. Small number is, in fact, equal to the value 3, so this boolean will store true. Another one. And make a new variable and assign it to a value. Number is not equal to 120. We use the exclamation point to represent not. So you can use it on its own, and it's logical not. We'll see that a little bit later. Or we can put it with another equals, and that says not equals. It's the same as the sign that looks something like this in mathematics. One more. Greater than and less than operators are exactly the same as in math. So number is greater than 120. I forgot to think about the value for this one. This one is going to be true because the value in number isn't 120, it's 100. The value number isn't greater than 120, so this will be false. Now there are other logical operators as well. So I'm going to write a logical expression and then talk about what this means. What the hell did I just do? This operator, the double bar lines, means or. It returns true if either of the things around it is true. So equals, not equals. Actually, they're both true. But even if only one of them is true, this entire expression, what's inside these parentheses, would return true. Double ampersand is the logical AND operator. It returns true only if both of the things around it are true. So I already said the expression to the left of it is true. What about the expression to the right? As I already said, the exclamation point is the not operator. So the value of greater is false, but I put the exclamation point in front of it. So now it's going to change it to true. And the AND operator is going to see that there's true on the left side and true on the right side. So it will return true for the entire expression. Okay, now let's talk about comments. I've been using these slashes the whole time to write this green text. In code, you can write comments in your code so that human readers can understand what's going on, or you can remember that you had some code but you don't want it to be running right now. This is called a single line comment when we have the double slashes. Single line comment. The computer will completely ignore this. It doesn't do anything when it sees this. It just goes on to the next thing. There's other kinds of comments. If I put slash and then asterisk, the computer automatically filled this in for me. You can end this with asterisk slash, and now I can make this multiple lines, and it will still do it. If I try to, when I hit return after this single line comment, this is code again. When I hit return after this asterisk comment, the multi-line comment, it's still a comment, and it automatically filled in this asterisk for me. I don't actually need that. It's still a comment. If it's not, it just looks a little bit nicer to other people who might be reading it. There's a special kind of comment with 2 asterisks here called a doc comment for documentation, and we'll look at that when we start writing things where you can use this. It doesn't do anything if it's just on its own. It needs to be in front of something else important. Finally, one more line of code. I'm just going to print a string. Why is it called that? Okay, so obviously the print still has the squiggly red line because print isn't defined. But you might also notice that this parenthesis has a squiggly red line, and it's telling me I need to insert a semicolon to complete statement. I forgot to end my line of code with a semicolon. This will not run. It will throw an error and nothing in my program will run if I forget a semicolon. So I need to end every line of code with a semicolon unless it's a particular statement that we talk about later. But every command, when you initialize or declare a variable, if you try to run any kind of command, you have to end it with a semicolon. That's all for this lesson. See you next time.